Thanks a lot for having me, for having us. I'm Clarisse, CEO of Defense. Actually, prior to launching Defense, I spent 10 years in investment banking. We're super excited to present you what Defense is, and good job in putting this together. This is already quite an exciting event. So first, a few words about who we are. So Defense has been incorporated now more than 2 years ago. We are 30 people. About 2/3 of our employees are based in Europe, 1/3 in the US. As you heard, I have a heavy French accent. I'm now based in New York. I've been based in New York for the past 3 months now, so we're relocated to the US as we're committed to really accelerate our commercialization in the US. We raised $14 million in seed round, and we basically signed our first customer in December last year. Since then, we onboarded a few customers for the first half to stabilize the product. And since June, we've been up and running and very rapidly growing and acquiring customers. This has all been possible thanks to basically a stellar team. Very quickly, David, our CTO, has already built a digital custodian. Sam Faisal, our CISO, was the previous CISO of BitGo. Josh will be presenting as over 16 years of product experience, including Google. And Kshanri, our chief scientist, was the previous head of lab at Robinhood. So what is it that we do? So at Defense, we basically build the first developer tool on the market that is enabling you to deploy your wallet infrastructure without having to have any concern or know anything about how to manage a private key or even a key shares. This was very important to me, and this is basically the reason why I actually started Defense in the first place. It was first because I couldn't wrap my head around the fact that we would all operate on decentralized technology, yes, taking our private key and give it to a BitGo or an Anchorage, that we're keeping it on a centralized way as well. The second point was that I was convinced that there was no way we would onboard the next billion users on blockchain by sharing private keys or key share, basically by performing private key ceremony. In my view, this was not at all scalable. So at Defense, we took a very contrarian view on what is custody and what is digital custody. Basically, we've completely separated the security of the asset, so the security of the private key, and the governance of the asset. In other words, we are deploying a distributed, decentralized, security network that is operated on MPC technology that will generate the private key. The only function of this decentralized network is actually to sign transaction when we receive an API call. On the client side has an API key that defines its custodianship. The access is actually secure via WebAuthn, and this is how we've basically come to the market with a new implementation. So what is it what we do? We basically SaaSified wallets, so it's make it easy for even a Web2 developer to deploy a wallet infrastructure through our API. We've built our security upon MPC, and we're actually committed to improving R&D on the MPC side. We've already have a patent, and this is why we've invested quite a bit on the R&D at Defense. DevEx is absolutely a must. At the end of the day, we're building an API for developers, and so making sure that it is programmable and it is fit to enable builders to develop any application on top of blockchain is our first priority. We're completely chain agnostic. We commit to our clients to integrate a new blockchain under 3 weeks and a new token under half a day. Today, we support about 25 blockchain, and we have 9,000 tokens. We're built to scale. What it means that our infrastructure enabled to build millions of segregated wallets. So not just derived addresses from one private public key pair, but actually millions of private public key pair. As you may know, in the aftermath of FTX, this will be quite important and potentially something that regulator will enforce. Last, we enable developers to enforce compliance internally, and we have the only API out there where you can actually program your policies at the API level, and it goes very low as to actually even being able to assign certain details of smart contract and create policies around it. These are a sample of our clients. Together today we have, I would say, mostly 60% use cases that are crypto, wallets, exchanges, staking, delegating app. On the other side, we have about 40% use cases that are more NFT focused, and we're really starting building use cases on the security token side. Last, our business model. Contrary to most of the technological service provider out there, we don't price based, and I'm talking about Fireblocks very openly here, we don't price based on AUM or AUC. We price our technology because we're a technology service provider, and there's mostly three metrics: is the number of wallets you create, the number of authorized user or signers, and the access you have to the policy engine. So it is a monthly fee based on an annual commitment. Josh, do you want to take over?
Yep, happy to. The chat is very active, Clarice, if you wouldn't mind jumping into the chat and grabbing that while I share the screen. Yeah, so good to meet everybody. Thanks again for having us. So demoing an API is not always the sexiest thing in the world, although I am going to take you through our documentation a little bit. But instead of demoing the API, I decided why not show you an implementation of our API with one of our customers, Nylos. So Nylos is a treasury management platform, and they aggregate treasury functionality. And they started with a non-custodial wallet, right? Not your keys, not your coins. And what they realize is not all of their users have the non-custodial wallet, and setting up and connecting a MetaMask is like a 30-step process, where if one of the critical parts of that process is you have to take the seed phrase, you have to write it down, and you have to secure it forever, or else you lose all of your funds. And we all know that. We've all kind of signed up for that as crypto native folks. But what we're trying to do is open it up to the next billion people who have no idea what non-custodial is. They have no idea what a crypto wallet is. And our customers want to try to create an onboarding experience that's totally seamless, is super fast, and just makes this experience feel trivial. Someone authenticates into the site, they immediately have a wallet. So instead of having the option to create a non-custodial wallet connection, they actually have just introduced a Nylos wallet, right? And so this Nylos wallet is a defense wallet on the back end. So I'm going to go ahead and click that and click next. And then I just pick my chain. They are supporting Ethereum and Polygon. We support 25 chains in total, so they could add those trivially to this list as they expand access to the chains. And then when I call create, we'll see this in a second, what's happening is they are actually calling the defense API in the background, and they're calling an API endpoint called create asset account with the asset of Matic for the Polygon chain. We are then issuing a call to our signer network to perform a distributed key generation ceremony that actually creates the key shares in these secure enclaves in a distributed signer network. So the private key itself for the blockchain is never actually materialized in memory or on disk at any time in that process. So there's no single point of failure like there is in other schemes. So I go ahead to the account, and now what I see at the top is we've got the wallet address. So they called that API, it's asynchronous. They then got back an ID and they called an API to say, give me the address of this wallet. And there, I've got it. So at this point, this is a fully functioning address that's predicated on an ECDSA encryption scheme for an EVM-based chain. And they can transfer assets to this wallet immediately, and all assets will be tracked on chain. Defense has no notion of an internal ledger, no omnibus or anything. Our business is creating and managing the private key shares that constitute the access to the chain. Now, once funds are attached there, they can send that money through a simple UI here, where you just pick a destination partner from kind of their whitelist that they've curated. You select the currency, you select the amount, and then you click next, and that initiates the payment. So again, this is pretty simple, straightforward implementation, but the actual calls they're using on the back end have made building an experience like this really trivial. So let's just go ahead and jump into the API documentation. So they're using what we call our high-level API, where we abstract away a lot of the complexity of actually interacting with the chains. We also have a low-level API for crypto native developers who are used to building in Web3.js and Ethers.js, where they can construct transactions, they know how to encode the data parameters, et cetera, to interact with any arbitrary smart contract on any chain. But all they're doing when I selected Polygon and said create, is they posted to assets create asset account, and they passed in a symbol of Matic for the Polygon network. And so we knew what to create there. And then we returned to them an asset account ID, which is basically like a wallet ID. They then say, well, okay, get this because it's an asynchronous call. And that returned to them the address field, which they then displayed in their UI. Additionally, they also displayed the balance. So they got this URL with that asset account ID in the path, and this would give them back the balance in that asset that is tied, the asset account is tied to. And in the Ethereum case, it's displayed in Way. For that bottom UI where they initiated a payment, they just called this initiate payment function. So here they're posting, they're specifying the asset account, which is the origin account where they're initiating the payment from. And then they have a number of different options to specify the payment. They specify Matic as the symbol, right? They specify the amount of the payment, and then they specify the receiver. And in this case, they can either make it a defense wallet or any arbitrary address on the blockchain. So here's the address, and that would kind of correspond to whatever address they have in their kind of internal address book. That then gives them a transaction body with a payment ID. They say get payment by ID, and ultimately when the transaction is executed through the mempool, which we broadcast to the chain after the signing, then we send them a transaction hash, which they can validate on any public chain explorer. All of this is subject to our policy engine and governance. So when they initiate a payment, our policy engine kicks in. Our policy engine is completely configurable via versus the API. A few folks in the chat were asking, well, why are you, or how are you different than Fireblocks? And there's a couple of ways, but one, we're API first, they're UI first. So in our API, we fully expose the policy engine. So you don't have to use, for example, the Fireblocks app to actually approve a transaction. You could build your own app and then approve the transaction and policy controls via that API. Just to finish up, because I know that we're probably running short on time. This is our kind of like API levels of abstraction to zoom the camera out. So again, we have kind of the higher level of abstraction, which has, we deal with more of the communication of the blockchain. And then at the very low level, for those power users, we have a raw signing API. So you can simply tell us, hey, I want to create a key, and I want it to use the ECDSA or an EDDSA signature scheme, which covers the vast majority of chains, including the 25 that we support. And then once you have that key, we have an API that allows you to just sign a transaction as if it were an HSM, and then also subject that to policy engine governance, which can act as like a multi-sig. So maybe that transaction requires a 2 of 3 approval from the policy engine, right? So we've kind of put all of that together in kind of a single API surface. On top of that, we have the ability to broadcast a transaction where you give us the transaction body, we hash, sign it, and broadcast it. And what we're introducing now is on the higher end NFT accounts. So you'll be able to transfer NFTs, view NFT metadata, et cetera, from the high level, and we deal with the integration with the ERC 721s. And then a smart contract API, which is right in the middle, which basically says, okay, just like composability in Solidity on chain, like you're calling an internal function from another smart contract, you'll just import an ABI to our API. We'll understand the fields, we'll know what contract you're calling, give us the 2, give us the function and the parameters, and then we will encode that into the data parameter for the specific chain, hash it, sign it, and broadcast it. And the ultimate vision is that you'll actually have policy engine and governance all the way down to that level where you can say, well, when I interact with Curve and I'm supplying liquidity to the 3 pool, right? If it's going to be over, 10,000 USDC, then it needs approval from like these 3 individuals internally, and it goes through our policy engine. So that's kind of our ultimate vision. All of this is secured by a secret that the client holds. It must be used to sign the API requests. And ultimately, we plan to publish those transactions on chain using Merkle trees, zero knowledge proofs, et cetera, so that all of those transactions are publicly accessible, but still privacy intrinsic. Okay, so yeah, that's our presentation. We look forward to joining you all in the breakout room and answering any further questions that you have.